Welcome back. This next section we're going to talk about putting the servo arms on the servos, the balls, getting the servo arms at 90, etc. But the first step in doing that is we need to set up the radio. Now this is a Futaba 7C HP. It's going to be a lot of differences between radios, but the basics are going to cover the same things. The menus may be different from radio to radio, but the bottom line is we need to cover the basic setup things to get us to a proper setup. So what do we want to do? Well, the first thing I would do is make a new model in your radio, reset the model so that all the trims, sub-trims, ATVs, and everything are reset. And we want to look for the following. Our trims are in fact centered. I'm going to go into the menu, and I want to make sure that our sub-trims are also all set to 0. No sub-trim in here at all. Okay. We also want to make sure that our we don't worry about reverse for yet. And we want to set our swash, depending on your radio, it may be different. For a Futaba, it's HR3, and it'll automatically, once you set all these to 50%. By the way, when you change the swash, it may reset all the radio settings anyway. I found that it does on Futaba. Can't say for other radios. In the parameter, of course, you want to make sure you've got the model type is Heli, PCM if you're using it, or PPM, and HR3. You know, those are basic things you're going to have to do on your radio. And then we want to look at the ATVs. By the way, turn off any Revo mix. Some radios default with Revo mix. Okay, and then the other thing we want to make sure is our endpoints for the radio are all 100% across the board. No 120s, 110s, or everything. We want to make sure we're reset starting from ground zero before we do anything with putting servo arms and trying to get them at 90. So basically, go ahead and set up your radio, get it set to this step, and then we'll go to the next step, and that is putting the arms on the ball and lining the arms up. Now, when we're doing this, what we want is we want the throttle stick at center. Most radios have a little graduation along the side here, and you can see there's a little mark that allows you to get the throttle at center. We want the throttle at center, especially on a CCPM bird, so that we can get the arms at 90. If you start off with the stick down here as you're trying to find center on the servos, it's going to be a problem. So throttle stick at center always, whenever you're getting to this point. Okay, now some radios actually have a menu where it tests the servos, and you can actually see a scale that shows where the stick positions are. You might want to go into that and move your throttle stick so that menu shows that the servo is actually at center and not a little bit one way or the other. If you don't have that, use the graduations on the radio. Okay, so I'll close with that, and we'll go to the next step, which is lining up our servo arms. Okay, actually, before we start lining up arms, I want to talk a little bit about how to go about doing it. Basically, if you don't, I like to use a receiver pack and plug it in the receiver. That way I'm not messing with power to the motor or the speed control and a big LiPo pack while I'm doing the setup. So that's the way I prefer to do it. If you don't have one of these, then you can go ahead and use your speed control, which has a battery eliminator circuit, and your battery. I recommend you keep the motor unplugged at this point while you're doing this setup, so you don't actually spin up anything. Okay. For this video, I have the head off, but you may already have the head on, and that's fine. You don't need it at this point. We're just getting the arm center. We'll work on the links later where we'll put the head in. But this is the way I prefer to do it with a separate battery pack. It's safer, but you can use your speed control in your battery pack. Just keep the motor unplugged. Now, let's talk about channel assignments for a minute here. For Futaba, the 3 servos that work the cyclic are aileron, elevator, pitch. Now that's going to be the same with any radio, but where they plug into the receiver may be different. Futaba, channel 1 is aileron, channel 2 is elevator, and channel 6 is pitch. Okay? On JR, I believe it's different, and other radios could be different. You need to find your channels and get your servos plugged in right. Now, bottom line, here's what they are. The back servo is elevator. These two front servos, believe it or not, it doesn't matter whether you have one is aileron, one is pitch, or vice versa. The radio mixing will allow you to correct either way. It really doesn't matter. I like to put the aileron servo on the right of the bird, tail pointed toward me, and the pitch servo on the left of the bird. So this will plug into channel 6, this will plug into channel 1, this will plug into channel 2 on Futaba. So again, elevator, aileron, pitch. Okay, but again, you can do it either way, and you'll see in the radio how to get everything moving right when I get into that step. Okay, so I want to talk about that before we actually start looking at aligning the arms. We want to make sure we don't change anything around after we get these arms at 90, because it may change the relationship of that. Okay? Okay, this next step before we center the servos is we got to get them moving in the right direction. Now, CCPM, it can be pretty darn complicated because you're messing with a couple of things. Reversing as well as the swash plate mixes and the direction of the swash plate mixes. So let's talk about that a minute. So we're clear what will be changing. In the reverse menu, reversing a servo only affects the channel you're reversing. So for instance, if I reverse the aileron channel, it will simply act upon this servo, not the rest of the mixing on the bird. So for instance, in aileron on CCPM, these two servos move in opposite directions to tip the swash plate. The elevator does not move. For elevator, back elevator, we want the two front servos to come up and the back servo to go down, and that's the direction there. So it tips the swash plate back and forth. And in pitch, all three servos move up to move the swash plate up for positive pitch. All three servos move down to move the swash plate down for negative pitch. So again, ailerons go like this. Elevator, back elevator, this one goes down. These two go up. Forward elevator tipping the swash plate forward. This one comes up. The elevator servo comes up. These two go down. And pitch, all three move up and all three move down. So it's part of the mix. So again, if we look at this and we see one servo not moving the correct direction, then we may just want to go in and reverse that one servo. However, if we find, for instance, that our servos are moving correct for cyclic, let's say, but for pitch they're backwards, what you want to do is not go in and reverse pitch. If you reverse the pitch servo, it will only change the direction of this one servo. It won't affect all three. So what you want to do is go into the swash menu, and for instance, if pitch is backwards, go down to the pitch mix and change it from a positive to a negative, whoops, wrong way, from a positive to a negative. And what that will do is that will reverse the mix for all three servos rather than playing around with reversing for just one servo. So remember, only use reversing if one servo is going the wrong way. Use the mixes here if all three servos are not working together in the right direction. Another example of that would be, let's say elevator, I pull back on the stick, and instead of these two servos coming up and this one going down, it's the other way. This one's coming up and these two are going down. Your elevator's reversed. You don't want to go in and reverse the elevator servo. You want to go in to the mixing of the swash and go to the elevator and reverse, make it from a positive to a negative, or if you have it the other way, a negative to a positive. Okay, while we're working with centering servos for now, we're always going to set these at 50. Okay, so go ahead and get your directions right. Servo reversing if one servo is not working the right direction, and mixing if all three are not working the proper direction. Okay, now it just so happens that, let me go ahead and set these back to 50. It just so happens that I got lucky on this radio, and rather than have to mess with a bunch of these on this particular setup, because of the order I put the servos in, the only thing I need to change is, let's take a look at this. Here is elevator. Now what's happening is elevator's going down. That's what we want. The pitch servo's moving up. That's what we want. The aileron servo is actually moving down. See, down. Okay, well that's interesting. How about pitch? If we look at pitch, Both these servos are moving up. This one's moving down. Okay, so two of these servos seem to be working. Let's look at aileron. Right aileron. Right aileron. This one's moving up, tipping the swash plate to the right, but this one's moving up as well. So looking at this, I'm going, hey, these servos are all moving correct. The problem servo is this aileron servo. So it's obvious what I need to do is go into reversing and simply change the aileron servo and reverse it. Okay, now that we've done that, let's check it again. We've got elevator. I pull back on the stick, elevator goes down, the two front servos are going up. I go forward on the stick, elevator's going up, two front servos are going down. Let's try aileron. I go right aileron, this one's coming up, this one's going down, perfect. Let's check pitch. Hey, look at that, both are going up, both are going down. Again, let's say I got to the point where cyclic was correct, but these were all three were not going in the correct direction. Again, I would go back into the swash menu, and on the pitch, I would simply change this from a plus 50 to a minus, and that would correct for all three movements. So, I hope this covers how to set up CCPM. It's the best way I can describe how to do it. Just to close on it, if one servo's not working correct, try reversing. If all three or two or whatever are not working in the correct direction, use the swash menu to change the mix from a positive to a negative. All right? Now, we'll leave these at 50 for now while we're getting our servo arms centered, which will be our next step. Later, once we get the head on and all the links on, we'll work with these percents to get the proper amount of throw. We don't need to do that now. Okay, so with that, let's now go work on getting these servo arms at 90. Okay, we're finally at the step where we want to do servo centering. Now, again, radio's on, throttle stick at center, all sticks at center, trims at center, sub-trims at center. We've set up the directions of our servos so they are moving in the correct direction. We wanted to make sure we did that first before we try centering these arms, because if we go and reverse it later, the center may change. So throttle stick at center. Also, someone did mention to me that I should make sure, as part of setting up the radio in previous step, we also wanted to make sure we didn't mess with any of the pitch curves of the radio. They should be linear at this point. 0, 25, 50, 75, 100 if you've got a 5-point curve. So I just want to touch on that. Anyway, let's talk about arms. The splines and arms are offset from the actual arm. What that means is, if I'm at center stick and everything, I can put this wheel on here and you can see that it's pretty close to being center now. But I might find that if I turn the arm around, that it may line up to center more, and actually this one does not. It's worse. See, as you can see, if I put it on there, it's pretty bad. So that's the way these work. So the object is here, we want to try and get an arm that's as close to center as possible. Now, the high-techs come with 3 arms. One's a small arm, you can't use it, but it comes with 2 of these. One is a single arm, and one is a double arm. It just so happens that the second hole out is 13 millimeters from the center, and on this arm, the second hole out is 13 millimeters from the center as well. So we can use either of these 2 arms. This one's nice because you don't have to cut off the other arm and that kind of thing, and it has larger holes for the screws for the ball length, whereas this one may get us lined up better, but we have to drill the hole out to get the screw in. Both of them are about the same thickness, so they're both fine arms to use. So what we want to do is find the best arm that fits mechanically. Again, throttle stick at center, so let's find it. Well, we put this one on here, and no, it's a little off. Let's try flipping it around. And ooh, that's pretty darn close. I might keep that one, but let's try the single one, because this single one is actually splined slightly different as well. And oh boy, that one's pretty good. I think I'm going to go with that arm on this side. Now do the same thing with the back and the same thing with the front. We want to find the arm that best gives us a straight alignment. And for that servo, I'm going to choose that arm, as you see. Okay, the next step, now that we've chosen this arm, the next step is let's get it exactly centered. And how you do that is you go into your sub trim. So I'm going to show that on the radio. We're going to go into the sub trim and go ahead and find it. Now, there we go, sub trim. Okay, go into that menu. Now, the servo that we're messing with, if you recall, on this side of the bird, that is the aileron servo. So we want to change the sub trim, plus or minus, to center that servo. So if we look again, I'm going to put the servo here, and we're pretty darn close now. And it looks like it needs to go maybe up 1 or 2 sub trims. And if we see, watch the sub trim move the servo. I'm going to move it a lot. Okay? It doesn't move much. Sub trim only moves a little bit. I mean, there's a setting right there of 70, but it's moved it quite a bit. So anyway, what we want to do is just change the sub trim until we get that servo centered. Now, I like to just eyeball. It's pretty close. You use the case as a reference and the tip as a reference, but you may want to make a tool. I know people who will take a straight edge and hold it along the holes and line it up with the top edge of the servo. But I think if by looking at this we can get this pretty straight. So right there's a sub trim of +2, and that servo looks pretty darn good to me. So now let's do the elevator servo. I've got another horn on there, and as you can see, well, it's probably a little too dark in there. It's not quite lined up. So again, I will go into the sub trim for elevator, and I will go ahead and adjust the sub trim of that servo until it looks centered. Okay, that looks pretty darn good. I've got a sub trim of 24. Okay, so you do that for all the servos and get them all level, and get your arms, which arms you want to choose. Same thing with this servo here. We do this one, and we'll just set this as pitch. So we go into the pitch channel and change the sub trim to get it level. Again, you find an arm that best gets you close. It's better to be close mechanically as possible first before messing with the sub trims. Okay. Now, if you do wind up using one of these longer arms, remember which way you found it best center. Mark the side that you're not going to use, and then go ahead and trim that off so you only have one arm. Okay. So now we've centered our servos, and I will go into the step next that shows how to put the balls on for the servos, and basically we will be done with servo setup. Okay, I've gone ahead and attached the balls to the servo arms for the front 2 servos of the heli. The balls go on the inside of the arms. This gives us the best shot to the swash plate. So I've done that for the first 2. Didn't need to waste footage with just showing people how to screw a screw and put a nut on. The only thing I'll talk about here is make sure you use Loctite on these nuts. You don't want those coming off and having your ball link come off your arm. So when you put this together, use Loctite. Again, for these high-tech servo arms, 13 millimeter hole, the second hole on these arms, happens to be the best. It's 13 millimeter. If you used one of these arms to get mechanically, it's the third hole out on one of these arms. You would have had to have drilled out the hole to accept the screw. You don't want to be forcing it. You want to drill it out so the screw goes in the hole nice, and put your nut on and use Loctite. And then trim off the other side that you didn't use. Okay? In my case, I wound up being able to use all 3 of these with very little sub trims, and so we're set. Now, the problem with the back arm is we also need the ball to be on the inside to get the straightest shot possible. The problem is when you look at this, you put one of these arms on, the ball will rub the servo case. So what I found is if you look at a ball, what I found is if you grind this standoff off of the ball, it will clear the servo case. If not, the ball will rub the top of the servo case and rub a hole in it and cause binding and everything else. Okay, so we need to grind that standoff. Now, a lot of people said, well, gee, that doesn't look easy to do. And how do you hold on to the ball if you're going to grind that off? Well, for sure you're going to need a Dremel tool. I like the Dremel tool with the cutoff disc. It makes a good grinder, or you can put a grinder on there. The other thing I definitely like to stress here is, now that we're using power tools, safety glasses. Never grind anything without these. You don't want a piece flying into your eye and putting your eye out or causing you to see the doctor. So always wear safety glasses. Okay, so here's the trick I like to use. This allows you to hold the ball without a lot of trouble. And if you try to hold it with pliers, you may put marks, especially if you're working with the aluminum balls. With the steel balls, you still can put marks, so you don't want to hold on to it with pliers. But this is a trick I found. Slide the ball onto a toothpick, put a piece of tape back here on the toothpick so it keeps the ball from sliding backwards. Then go ahead and get a set of side cutters and cut the toothpick off right where the standoff is, okay? And that will hold our ball. And then what we want to do is we don't want to go after this aggressively. You're just going to take your time and grind slowly. Okay? Again, safety glasses on. Now this is a steel ball, so it'll take more time. But, you know, you don't have to go whacking at this all in one big fell swoop. Just take your time and grind the ball down slowly. Okay, I'm about halfway now. I'm going to bring up the RPM just a little bit. And just keep working at it. Okay, I'm not going to burn video time here with trying to get the ball all ground down. I'm going to go ahead now and finish grinding the ball, and when I come back I'll show you what it looks like and we'll put it on the servo arm. Okay, so I've got my ball all ground down, no standoff, and we're ready to go. Now if you look at these balls, I didn't show this when I put these other arms together, but the ball has a tapered hole for the tapered head of the screw. Obviously we've ground the standoff off, so basically it's pretty simple. Put the screw in, get it ready. We want the second hole. Now as I said, you want to drill these out just a little bit because you don't want to really be threading that screw in there hard. It tends to warp this plastic. Okay, and then we just take our tool and we've got the ball ready. We go on the inside of the arm, second hole for this arm, third hole if it was one of the other arms. Go ahead and screw it on. You're now on the inside of the arm. As I said, it will not rub the servo case now. As you see, it gives you clearance. The ball is not rubbing that top of that servo. So we're set. I'm going to go ahead and apply some thread lock, put the nut on. We're good to go. And basically we'll return and show the completed servo setup, and that will be it. Okay, so we're done. Basically, we have now got the servos set up. Again, center on the throttle stick, all arms at 90 now. When we move pitch, all three servos go up. Okay, we move aileron, we got those in the right direction, elevator, and those are in the right direction. So basically that's it. Some people, while I was putting this video together, talked about ATVs. We don't mess with ATVs during any of this step. As a matter of fact, the next segment I'm going to do is we'll put the head on and we'll start working our way with the links up through the head and get that all correct. This segment was just about servo centering. In the following segment, we'll talk about how to control how much throw, that's in the swash mixing, and how to get rid of any CCPM interactions at full top and full bottom of the pitch. That will come in my next segment. But for this segment, it covers the servo centering and using the sub trim, setting up CCPM for your directions and everything else. So that's in summary. We're basically done, and I hope this was helpful to you.